Welcome to this session about what is visual AI and how can Applitools help teams power their quality journey using our amazing features and capabilities. I'm Anand Bagmar. I'm a quality evangelist and solution architect with Applitools. I'm based out of Pune in India, but I do travel across, rather I used to travel across when travel was easier to meet with all our partners and customers and help them understand and learn about Applitools and about quality practices. So today we will, I'll share my perspective of what is visual AI, how it can help, and how in my course of 20+ years in quality, how this is truly a game changer that I have come across. I don't say that too often about many other products that I've seen. So let's get started. I want to start off by saying that today's approach to automation is not working. In fact, it is broken. And that is a very strong statement from someone who's been focused on doing automation, functional automation for around 20+ years, including open source and commercial tools. But the reason I have the confidence to say this, and it's not just me, it is based on data that is captured from a lot of industry leaders and experts as well, is we write a lot of code to automate very specific functionality. We only write code to test if specific features and functionality is working as expected. But we do not, and it is not easy to write tests for things that we do not expect to happen. Automation is a very deterministic way of working. So with the agile way of working, where we are continuously evolving our product, the product undergoes change and the locators, the UI user experience keeps changing as a result. It is first of all very challenging, almost impossible to keep your automation in sync seamlessly as your product is evolving. But it is possible in various ways as well. But whatever said and done, you cannot prevent defects from going into production. And what we hear from leaders in the space as well, there are a lot of other challenges also that it comes to when it with functional automation. Test creation is slow. It takes a long time to write new tests. Any small change in the UI, the tests fail. As your test framework grows, as your number of tests grows, there are a lot of growing pains that you go through in terms of maintaining and scaling your framework. There is a challenge when it comes to running your tests across different browsers or devices. The feedback cycle is extremely slow, but you still continue pushing forward and doing as much automation as you can. The end result is still that defects escape. And yes, it is software. There are going to be defects in the product, but could there be defects that we could have caught easily, which are still ending up in production? Defects like this, where everything, all functionality seems to be fine, but some CSS is broken, which means the content is overlapping and the user is not sure where the click on the continue button is really going to go. Is it on the fair rules, or is it actually going to continue to purchase the ticket? For that matter, would the user really even attempt purchasing a ticket in this fashion if the UI was broken? I would not know what type of behavior it's going to be, right? So it's a big problem. And you will see such types of issues in any type of product or domain, whether it is Yelp, whether it is Instagram and native apps, whether it is banking sites. It does not matter whether it's a B2B product, a B2C product, whether it is web, mobile web, native app, hybrid app, it does not matter. Issues escape into production, and there are issues which could have been caught before it goes to production to make your life easier, make the life of your users easier. So this is a very tough spot because you're trying to do a lot of automation to make sure your quality of the product is good and you're getting quick feedback. But it is a very difficult situation to be in because your application is always going to change, which means it's a constant battle between how much time do you take for testing and updating your automation versus releasing faster. And that's where eventually the efforts of automation start giving you negative ROI because you're spending more effort for the value that you are getting in. And as a result, for every defect that still escapes into production after all these efforts that are put in, your business loses brand value, your users are not able to get the value from your product, and hence finance also gets impacted. Revenues get impacted. So it's a lose-lose situation as you need to continue scaling in a fast-moving environment. And hence we say that there is a different approach that is required, and that approach is what we call as visual AI. How can we use the power of the computers to tell us exactly what the human eyes and brain can see on the screen? And how can we leverage the power of the computers to give us this information about what is there on the screen, and then let the human mind take a decision on what is seen, is that right or wrong? Okay, so let's see how this visual AI really works. Let's take a simple example of a login page. The expected functionality over here is if I do not enter username password, if I click on sign in, I should be seeing validation error messages over there in different colors as well. So if I have to write a simple Selenium based script for this, I would potentially end up writing one line of navigation, one line of button click, and then there is a lot of validation code that we write to make sure that we are seeing the correct error messages in the correct style over there or not. Now that's a lot of code, lot of locators that are required for a very simple test. And this test, to top it off, takes a long time to create as well. It takes almost an hour to create this because you have to identify the locators. You will run the test multiple times, make sure each and every assertion is going to work correctly, and that takes time. However, if you were trying to implement the same test using Applitools Visual AI, the test would actually become very simple. Essentially, there are just 3 lines of code that you need to have: one navigation, one click, and actually what you need is just one single line of code to do the whole validation, and that is eyes.check window. All you need is this one line of code, which is going to tell you if your functionality and user experience is working as expected. And this type of test takes maximum 2 minutes to write because there's just one locator that you need, and your test is ready. The types of differences that you would find as a result using these two approaches is phenomenal in that sense, though. All the defects that all the areas that have been highlighted in these dotted red areas are differences that have been found as compared with the older version of that same login page. But a traditional Selenium test would not find the overlapping content, the missing image that is there, or the new functionality that has been added as well. In fact, your Selenium test would stop at the first assertion that failed. Even though you had a lot of assertions implemented, the first assertion that failed, the test would stop over there. The rest of the assertions would not even be executed. And that is a big problem. So now if you are still using a traditional approach, you would spend probably another hour trying to see what other types of validations can you add based on the new functionality, the new issues that you have seen that were escaped. You try to update and add more assertions in areas where possible. In many other areas, you would quickly give up because it is not possible to use Selenium to do that type of validation. So now you have essentially spent more than 2 hours for a simple login test. You are able to find a fraction of the defects, and you're also getting a lot of false positives in your validations. However, if you use Visual AI in this case, you would be able to implement your test very quickly. There is less code that you are writing, hence the stability of your test code also increases tremendously. You are able to find 100% of the defects that were existing on that were found in the new UI. All of those would be captured and reported to you, and there are 0 false positives. With this approach, Applitools will be able to present to you all the changes that are seen on the screen as compared with the expected UI, and you as a person on the team have the intelligence, have the context of what is changing in your product to say which aspects of those changes are valid changes, which aspects are defects that have been found for which you need to take some action on. Okay, so another important aspect before we move into the demo is to understand that visual comparison, there are different types. The traditional approach is pixel comparison, where I'm comparing pixels of one browser with the one screen with the other. And that is not a scalable solution at all for multiple reasons. The browsers control the rendering engine. So even between browser versions, even though everything is the same, if the rendering engine has some change, your pixel comparison is going to fail. It will give you false positives of differences found. Between if you have any dynamic content in your screens, in your pages that you are trying to compare, you are not going to be able to use pixel comparison for that, because of course there are going to be a lot of changes that are reported which do not make sense. Hence, visual AI is the way to proceed. Visual AI does not use pixel comparison. It does not focus on the rendering differences. It focuses using AI technology, what is really important to the user for validation, and it will highlight you the changes based on the algorithms that you have chosen. And we'll be talking a lot about this in the demo very shortly. So with this example of a login page, I want to reaffirm the importance of the combination of functional and visual validation that adds tremendous value for their team. You're still going to use your standard automation tools, whether it's Selenium, Appium, or any other tool. You would still use those tools for driving your application under test to simulate the functionality that is required. So if you're using Selenium, you will still use Selenium to interact with the browser, to do actions on the browser, to get information from the browser. But you will not be using any standard assertions like TestNG assertions, for example, JUnit assertions or Assertions. There are so many assertion libraries. You would not need to use those assertion libraries for validating the behavior. You would instead use the visual assertion like Applitools eyes.check window to do your functional and visual validation all in one single call. And this call can take care of the whole page for you, validate the whole page for you, or you could also customize it and say, I want to validate only a snippet of the page because that is what is really important to me. So a single assertion can give you functional and visual coverage and user experience validation as well. Because of this, you don't need any additional locators as well. The number of locators required have gone down tremendously because all you have just the locator required for the navigations. All the other validations are taken care of by Applitools. You have a lot of different other features and capabilities which we'll be seeing in the demo, which makes this a very comprehensive solution, a very valuable solution to adopt and use with your functional automation to get a wider coverage. So what really is Applitools Visual AI? Applitools incorporated in 2013. First product was launched in 2015. Our mission is to help teams release perfect apps at a fast pace at a reduced cost. And we solve a lot of different use cases, whether it's functional testing, visual testing, web, mobile, or cross-browser, cross-device testing, compliance testing, and many other feature sets that we have. We are the inventors of Visual AI, and we'll help you work in any way that your team is structured to work to get faster feedback on the quality, where you will be able to take decisions on the differences found in a very meaningful and quick fashion and make your product quality better. We genuinely use AI as our core technology to do this validation, unlike a lot of other products claiming to use AI as a buzzword. Our AI engine, and as we'll see in the demo, shows how you will be able to get value from this right from integration. There is no training or algorithms required to be manipulated or changed to work in your environment. You just integrate Applitools with your framework and you are ready to start visual testing. So our platform at the core, of course, is the Visual AI engine, but the way we are designed, we help integrate very seamlessly in any tech stack that you might have from a development, testing, DevOps perspective. We are able to work in any way of working that your team might be having, and it's a very collaborative tool. This is not a per user license that we have. It is a team license that Applitools offers, which makes it very inclusive for all roles to participate in looking at the results and take decisions quickly. Our Visual AI technology helps you increase the test coverage And with our feature of the ultra-fast grid, you'll be able to scale very seamlessly at a very rapid pace and get extremely quick feedback as well. And the evidence of all the data that we have from the usage of a platform and the various different studies and surveys that we've done show that test authoring is 5.8 times more faster. The test code itself is very efficient, almost 6 times more efficient. The test code is also 3.8 times more stable because we are reducing the brittleness in your tests, less locators used, and the test coverage increases by at least 45%. Rather, the number of defects caught on an average is at least 45% more than before when you're using Visual AI. So that becomes a win-win situation. A quick note about the ultra-fast grid that I was talking with you about. So at the core, of course, is the Applitools eyes, the Visual AI engine. But to help you scale, instead of using a traditional cross-browser testing techniques, where if I have 10 tests and I have 3 browsers that I'm supporting, I'm going to run the same 10 tests across the 3 browsers. So essentially, it's 30 tests that I'm executing. And that is not really required because our browsers are W3C compliant. If the test works correctly in one browser, you could be rest assured that your test will work functionally in all the other browsers as well. But the difference where it is still seen is each browser has its own different rendering engine. Hence, even though the functionality works correctly, the way the screen is rendered in different browsers or devices might still be different. And that's where you need to do visual comparison across all your different browsers. And that's where the ultra-fast grid becomes a very, very powerful solution, where as part of your test automation, you can use any of our SDKs. We've got more than 60 different SDKs that we have available. You could use any of those SDKs to integrate Applitools in your functional automation. Whenever you do a visual validation, Applitools will capture the DOM and CSS information, send it to the ultra-fast grid, where it will render the same page in all the different browsers and devices that you have configured as part of your Applitools integration. And you will get the visual validation across all these different browsers and screens in parallel, asynchronously, and the results come back to your same executing test. So though your test ran just once, you will get the feedback of your functional and visual validation across all of your supported screens automatically using this approach. And that becomes a very, very powerful way of proceeding. We also have a very promising, equally promising feature coming for native apps. Right now it is in beta for iOS. Very soon we'll be having it available for Android native apps as well, where the similar approach will work for native apps. You run the test on one device or emulator and automatically you will get the visual validation across all your different supported devices as well. So you don't really have to run your same functional tests against a device and repeat that for each supported device. With that, the last slide before we move into the demo, here are some known organizations which are using Applitools for very different purposes, but Visual AI is still giving them a lot of value. So Slack uses it for comparing visual and functional regression testing. For every new change that comes across, automatically they run the test and they get the feedback, the differences found on a Slack channel itself. Adidas uses it for before and after deployment, so monitoring before the deployments before and after, making sure everything is fine. Bayer is using it for document validation, compliance validation perspective. Capital One uses it for responsive web design and cross-browser testing. Microsoft is using it for graphic page design comparisons. So a lot of different use cases can be achieved by using Applitools. As I mentioned, there are more than 60 different SDKs available, and you will be able to see that on our tutorials page as we see in the demo. And also, there are a lot of different tools and products that have built their own integration with Applitools as well. So that also becomes a very comprehensive and easy way for customers to adopt Applitools because there's a very low footprint in terms of integration required for this. So with that, I'm going to stop talking about from slides, and I want to actually show you how this works in practice. OK, so I'm switching to the browser now. I hope my browser is still visible. If you go to the applitools.com/tutorials page, you will see all the different SDKs that Applitools has built and supports to help you integrate with any of the tools that you might have. So if you're doing Selenium with Java, you could just come to the Selenium with Java for Java tutorial, and each tutorial is detailed. It has video recordings, code snippets about how things work, how to get started in a very easy fashion. And it's a very, very seamless integration that is there for sure. Likewise, so we've got support for all Selenium language bindings, all Appium language bindings for a mobile web, native web perspective, and many other tools as well. In case if you are using any tool for which we do not have a SDK support, as long as your automation tool can take screenshots, then you can use one of our screenshot SDKs to take that screenshot, upload it to Applitools and get the validation results from there. So that is also possible. We have some desktop SDKs and codeless integrations as well that you could use based on your context. But now what happens when you integrate Applitools with your functional automation tool, which is a most powerful use case, by the way. There are other use cases as well, but that is a most powerful use case, integrating visual testing with functional. Once you have integrated this and you run the test results would come to the Applitools dashboard. And in this Applitools dashboard, what you will be able to see is on the left-hand side is what we call as a batch. Batch is a group of tests that I've executed. You could think about it as your smoke suit or a sanity suit that is there. Inside each batch, you will be able to see the list of all those tests. And in fact, you can start seeing the summary results of what has happened in that batch execution. In this particular case, there were 6 tests in total. There were 5 unresolved and 1 passed. Now, what is this unresolved test? Applitools uses AI technology to give you with 99.49% accuracy if there is any difference that is seen on screen when compared with the baseline. Applitools gives you that guarantee, 99.49% accuracy. And this number is based on more than 1 billion tests that I've run on the Applitools platform so far. So now, based on this accuracy, Applitools can tell you with guarantee that these are the differences found. But Applitools or no other tool for that matter can tell if this difference is because of an expected change or is it because of a regression issue that has crept in. Only you as a team member will know after looking at the difference to say, yes, my product functionality has changed. Hence, this difference is not a valid difference. I need to update my baseline, or this is a difference that is a defect. I need to report this as a defect and get it fixed. So the AI engine is telling you with assurity, with guarantee, with confidence about the differences. And now you are free to explore other aspects to build a quality product. And when you look at the results, you know any difference found is something either a product has evolved or there is a defect that is found. And hence we mark it as unresolved. This unresolved is something for you as a team member or your team to come and take a look at and take decisions on it. How do you take decisions? That is the key aspect, right? So let me start with showing some capabilities over here. So let's start with a simple case of a browser comparison. What you see on the left-hand side is the baseline. Baseline is almost like your golden copy. This is what you are expecting to happen in your product. On the right-hand side is the checkpoint or the screenshot that has been captured when your test ran. It is also talking about what is the algorithm used for comparison, what is the OS and browser and viewport size that was used for baseline as well as the checkpoint. Now in this case, before I show you the AI algorithm, this is how the pixel comparison would work for this particular screen. It's a static page. And yes, I am comparing Microsoft browser with a Google Chrome browser. So the rendering engines are completely different, not just a little different. They're completely different. And if I do a pixel comparison, which is what the exact algorithm talks about or refers to, at a pixel level, the whole screen is different. Even though if I toggle between the baseline and the screenshot, you would not see all the differences over there. There are definitely differences, but the whole screen is not really different over here, right? So this is where the pixel comparisons are going to fail for you. Any tool that gives does pixel comparison is not going to scale at all. However, if you use the AI algorithms, now in this case, I'm going to use the strict algorithm. With a strict algorithm, you see the number of differences highlighted are significantly lower, right? And if I again toggle between the baseline and the screenshot, you will notice whatever is genuinely different to the human eyes, that is being highlighted by the algorithm for you. So now you can come over here and quickly take a look at all these differences highlighted and say, I don't care about certain differences, I care about certain differences, and you proceed. It is so much more easier for you to take decisions in this way. However, in this case, the strict algorithm also might not be the right algorithm. Why? Because I am not doing an apple-to-apple comparison. I am doing an apple to an orange comparison over here. These are two fundamentally different browsers. The way the comparison would happen, there are bound to be rendering differences. So this is also giving you some form of false positives in terms of differences found, because you're force comparing one type of browser with the other. But if that is really the case and you really need to do that, in that case, maybe the layout algorithm is going to add more value to you, where in the layout algorithm, we say, I don't care about the content differences. As long as there are any structural differences in the page, highlight those to me. And with this layout algorithm, we are able to see there is one change found in the bottom right hand side of the page, which is being highlighted as a difference found using the layout algorithm. And you are able to find a genuine defect in this way. OK, now it could be a defect or it could be an evolved functionality for that matter, right? If it is an evolved functionality that going forward, we are going to see the UI in this way. What I would do is I would just do a thumbs up, which is going to accept the difference. And after I do a thumbs up, I would need to do a save to say my baseline needs to be updated for it. However, if this seems to be a defect, and if you have a Jira or a Rally integration for defect management, I could report this as a defect to say content missing. And with the integration in place, you will be able to create that defect. And at this point, you would do a thumbs down. When you do a thumbs down, now this has been marked as a failure and you see this in red. You would see it over here as well. I have not saved it. That's why it is still not showing as red over here. But over here, it has been marked as failed. That's why you're seeing it like this. Right? So this is how easy it is to take decisions on when a comparison shows up on screen. Do I do a thumbs up? Because the checkpoint that I have now captured is the new functionality, and save it. Hence, you will be able to compare with that going forward. Let's take a few other quick examples. This is a finance app, native app. And because it's a finance app, data is going to keep changing, even though I'm using the same OS and viewport size. Now, in this case, with a strict algorithm, I'm seeing all the differences highlighted. If I use a layout algorithm again over here, you would see the number of differences highlighted are very less. Now, in this case, you are again getting a genuine defect that has been highlighted to you, that OK, there is something missing in this particular functionality. So you could log it as a defect and report it to the developers. However, if I go back to the strict algorithm for a minute, you might say that I don't have control over the data, but strict algorithm is the right algorithm for me to use, right? Because it tells me genuinely if there's any difference over there. So you could use actually a combination of algorithms. So for example, you could say I don't have control over this data. I just want to ignore it from my comparison. And this is going to be ignored for you. I had created the defect earlier itself. That's why it is still tagged. Otherwise, this would not show up as a difference because this whole region is ignored. I could also say instead of ignore, I want to use this as a layout region. I don't care about the content in this particular section, but I care about the integrity, the structure of this particular section, if that is fine. And you could actually use a combination of algorithms. So the whole screen is in strict, this particular region is in layout, and you could add as many regions as you want in this particular fashion. OK, so that's what the power of the algorithms is, which makes it very seamless to use, whether it is web, native apps, or anything. Here are some quick other examples. This is now USA Today, a media site. If you look at it, the whole page is completely different, but because I use layout algorithm, it is marked in pass. if I take another quick example of localization, over here I'm comparing there is something different in the structure of the page it is finding over here. That's why it has highlighted that. But the rest of the screen is marked in pass, even though it's completely different language that is there. So you could use such combinations of tests as well on algorithms for serving different use case perspectives. The last thing which I quickly, last 2-3 features I quickly want to talk about is running at scale, the Applitools Ultrafast grid that I was talking about. So I ran 2 tests which I could group by the test name. I ran just 2 tests, but because I ran it in the Ultrafast grid, I'm able to see the differences automatically for both of these tests for all my supported browsers and viewports combinations. And you can see based on the rendering itself, just simple rendering, the way the pages are rendered, that is different. But Applitools is automatically able to give you functional and visual validation across these screens, and you will be able to take decisions on those accordingly. So even though you're running the tests across all these combinations, to make it easy for you to take decisions, you could group the test by similar differences. You come and inspect one of the groups. You see over here the difference that is highlighted is a logo color has changed from black to green. This might be a change in functionality. So going forward, because of rebranding, my logo color has changed. So I do accept over here. I go to my next bucket. Instead of a green logo, the logo is missing. This is a defect. I'm just going to create a defect and I'm going to do a fail. And with a few clicks, I've taken a decision on all my steps that I've executed. So that becomes a very compelling great way to scale your execution and see what the differences might be. We have some features for accessibility as well. A lot of organizations, especially Europe, US, Australia, a lot of these regions, the products need to be following a certain accessibility criteria to make it inclusive. And if you click on accessibility over here, this would of course work for web native apps, PDF documents, images, doesn't matter. With accessibility checks, you will be able to highlight at WCAG 2.0, 2.1 levels or level AA, AAA and see if your product meets your accessibility criteria. And accessibility criteria in this case is contrast advisor only, because all the other types of accessibility checks can be done at your build time itself. As static analysis, you'll be able to check for a lot of that. But how is your product really getting rendered, and is it going to be easy for the visually disabled people or impaired people? This feature will help you validate that in a very seemingly and in a quick fashion. Okay, so this can be again a very important way to take decisions on if your product is meeting all the criteria, all your requirements as well. We don't have time right now, but there are a lot of other features like A/B testing. There is root cause analysis actually, which is an important one. I'll quickly show you what that feature is. So if there is a difference that is highlighted and you have root cause analysis enabled, if you click on a difference that is clicked, okay, let me try this. Root cause analysis. Oh, I have not uploaded with the DOM changes. Let me quickly find another check over here. You need to enable sending the DOM information to have root cause analysis enabled. So here you go, you click on any difference and Applitools will tell you what are the differences in the DOM or CSS that has caused the failure to happen as well. So these are some very interesting capabilities. Sorry, this was really rushed, but in the interest of time, I just breezed through giving you a highlight of some features and capabilities. There are definitely a lot more in terms of helping you work with A/B testing or multi-branch testing and keeping your, how do you manage baselines in that case?
Okay, maybe Anand, there's some room to show something else if there are no questions.
Sure, definitely. I would love to show some more features and capabilities. Okay. Okay, so this is an example of PDF document validation where you just feed Applitools a PDF document, and each page of the document will be considered as a single screenshot, and the comparison happens with that. The AI algorithms work with PDF documents as well. So it will be the same process as others to use this. And you will be able to, again, do a defect management tool integration as well with this particular approach. The other aspect that is good to know is, let's find some good use cases. Yeah, so this is again a good example. So there might be cases where you want to, your UI changes based on certain data. So for example, if in the top header, we've got 𝗕𝗏, NASDAQ and crude, and depending on the data between Dow and crude and NASDAQ, the NASDAQ section will move left or right to align correctly, have equal space between them. So the way we saw ignore and floating, ignore a region or layout region, we could also set this up as a floating region. When you mark this as a floating region, what Applitools does is it will create two different boxes around the area that you have done, which you could select. And what this now means is, as long as the inside box is within the outside box, it will not mark it as a failure or as a difference found. So that gives you flexibility to adopt your visual testing based on certain dynamic behavior of the UI in your application as well. And that becomes a very powerful way in some use cases to look at. Mm-hmm. The other example that we could see is for long pages. Applitools supports long pages as well, but many a times you would see small changes in the page can have a cascading effect in terms of difference found by the algorithm. It could be an image change or a content change that has happened. So what you could do is you can hide the changes caused by displacement differences. And what Applitools will do, it analyzes the page and figures out which are the changes which were because of displacement issues, and it will hide those off. And now you are able to focus only on the differences that truly matter. So now you'll be able to see, I'm going to start scrolling through and see, okay, the content over here is different. S has changed into a question mark. This is a very small code snippet that was there on the page, and it is able to tell exactly where the differences are in those as well. Right? And if you see, if I go back to this particular page, the code snippet was actually a very small portion of that page. Now your functional test could have been just about one very small portion of your page itself, right? But by just using a single call to eyes.check window, you're able to get the full page validation. So you don't have to write tests for each and every locator or position or element about it. As long as the context of your test is the same, you should be expecting same behavior from your product. And using the combination of these algorithms that I mentioned about strict, layout, content, exact combined together, you'll be able to do that very seamlessly. The other aspect, the algorithms that I showed you about, you can select different algorithms at different levels, right? I showed this to you from the UI. You could very easily do this from code as well. So here is an example where I am saying in this particular case, I want to do a visual comparison only of a specific element which is found by this locator. And for that validation, I want to use a different algorithm. I could also do, I have a default algorithm that I set for my test execution, but for specific validations, I could override that automatically from my test. I don't have to come through the dashboard to make those changes, because the test automation is a very deterministic activity, right? So your test implementers would know what type of algorithm makes sense for this type of test. And you could script it in that way, And this is a better way of doing this or doing the customizations instead of from the UI, because in the UI, when I select this region, I might not be selecting the complete element. For example, I might miss out a few pixels here or there, which may lead to unexpected behavior from my validation perspective. But if I do this from code, this is going to find based on the element, the exact region that is there on the screen and do the validations accordingly. And that becomes a very robust way of implementation as well. The other aspect that I wanted to speak about, show for the Ultrafast grid. So my test itself, if you notice, before I show this particular code, my test is actually a very simple test. I'm doing some navigation using WebDriver. I'm doing some actions using WebDriver over here. And this was a demo code, that's why I have so many validations. But all my validations are happening from 𝗕𝗏𝑐𝗄𝗃 window type calls. There are different ways how you could invoke the visual validation to give you more control. But these are the only calls that are required to be added in your test. So the test implementation has become much more simpler as well. There is some boilerplate code that is required, the way you would create your browser driver, for example. So in your before method, where you're creating your browser driver, you're also instantiating Applitools over here. So automatically every test is going to instantiate Applitools. And in the after method, you are going to get the results from Applitools. And in these results, you could have just one assertion to say there should be no differences found. So my test is still going to fail in CI because of either functional or visual validation results. But you're getting a much more wider coverage, and this wider coverage includes accessibility validations as well. So all those validations also will come up at the same time. Now, just one last aspect to add over here. When you're doing the Applitools configuration, if you're using the Ultrafast grid, you can specify, oops, wrong method, sorry. You can specify which are the different browsers and viewport sizes that you want to automatically do your visual validation. So I'm going to run the test only on my single machine, single test on my machine, or it could be a CI machine, doesn't matter, dev machine, CI machine, QA machine, does not matter. But whenever I say 𝗕𝗏𝑐𝗄𝗃 window, I have added so many different browser and device combinations, portrait mode, landscape mode, anything. I have specified this configuration once for every test, and automatically when my test executes, I will see it in the dashboard over here. Let me quickly show this to you. This was the test that I ran for it. So one test, there were so many different combinations that it ran for the specific browsers, viewport sizes, or the devices and their viewport sizes that I had specified. So one test execution and you get this comprehensive execution results, and your test can fail because one of your browser or device combinations did not render as expected. Everything else passed, but your test is still getting the same feedback as you would expect it to. So these are some very interesting ways of using visual validation. We also have some visual locators in case if there are aspects where you cannot interact with the element for some reason, or your automation tool is not letting you interact with some elements. You could create a visual locator, give it a name. I need it to be a smaller locator. And when I have saved this locator, now in my test, I can query for the locators on this page and interact with it the way I would interact with a Selenium WebDriver, for example. So these are some of the use cases that or advanced features that you could use to get a validation. Okay. So